All right, so there will be a slight delay, I believe, from when I see your guys' kind of questions and things like that. But feel free if I see we have some people here, so good to have you guys. But let me see. That's something I need to do. I need to add Discord. Okay, that is done. Wow, that's huge. That is bonkers. Oh, sorry about that. I feel like this might be a little bit confusing. All this means is that like what you see over here involves student names, things I don't want to necessarily show. So let me adjust that so it's a little bit clearer. Because the door's closed, but that's not really the right wording, I don't think. Let's see, let's see, let's see, let's see. Oh, that's that I should add to this list though. When do I want to do that? I'll probably do it before then. All right, hopefully that makes more sense. But yeah, if you have a question, go ahead and send it in. I bet this is like the worst way to do it. It's about the ECCP unit conversion section general. Great. Awesome. Awesome, awesome, awesome. This is great. Okay, awesome. This is great. We're going to talk about unit conversions in general. And what I love, again, about doing this kind of stuff is because it is recorded. We can always cut up things that I like about what we say here, what works for this student, what doesn't work for this student. And again, we're not expecting to like solve all of the problems, but starting to get a little bit more comfortable with, I think, what the heck do units mean is something that, let me even turn off my music before I get too lost in that. So, yeah, units are really, really cool. Because you might want to ask yourselves, well, let me make sure I'm not going too far. Yeah, unit conversions in general. So, okay, to even start kind of as I'm getting all my stuff together to get my iPad ready for this, but when it comes to unit conversions, it's important for us to always build on previous knowledge, previous things we feel comfortable with. We want to avoid as much as possible making these large leaps where it feels like we're learning something that has nothing to do with previous things we've learned, has nothing to do with our life. We want to avoid that much as possible. There's some pretty strong belief that the best way for education to happen involves always making sure the new knowledge the person is trying to take in and understand has to build on previous knowledge for it to be the most effective in terms of its retention. And so we're going to try to look for that even with units. When I talk about it with this student, talk about conversions. And I think this is kind of a topic that it seems very, very simple, I think, to some people after you do it for a really, really long time. But also, it is probably one of my favorite topics because it represents the first time I got really excited about chemistry, because someone started to explain some things to me and it happened at just the right time where I was able to, let's leave that there for now, where I was able to figure out some little tips and tricks on how to feel better myself about all the stuff I was doing. So let's get this up. Okay. Oh, why are you not charging? Nice, okay. Okay, that's looking good. Okay. Good. Okay, so let's first just talk. Me and Alex are going to kind of get a little discussion going on where they stand with units. What do they know about units? Because I don't want to, completely just start like going into it with my understanding of it, because we might not be necessarily at the same place with what we want to talk about. So sure, let's open one of those. Let's see if this is going. And let's make sure it looks okay on stream. I think it does. Okay, and it's the only thing I don't like about this program. Okay, all right, That's something. It might work. Okay, we're very close. Very, very close. Okay. Exactly what I wanted. Sorry, there's a touch of a problem with my iPad screen being sent over. Try it again. Nice. Okay, that's looking good. Send it full screen. And go here. Okay, I think we're there. So we should see my screen now, see my iPad thing. Let's see how it's working on this end. Go to Canvas. Oh no. Okay. All right, Alex, sorry for the delay. Are you still there for me? Just let me know in the chat if you are. And let's see, what is our timestamp at? 40 minutes, so about 40 minutes. Yes, okay, awesome. All right, Alex, so let me first make sure I can actually see what you're kind of saying. Okay, I think I can. Go to start broadcast. Nice, that's looking good. Okay, so first, let me kind of say that a unit is one part of two So this is where I want to start with units, and we're even kind of starting to prepare me for how I want to talk about this in class on Wednesday, because we do have Labor Day off, but I'll be in the office on Monday to help with anything. But so yeah, we have these units, and it is part of. Oops, it's part of the two things we need to use to explain measurements, because at the end of the day, science is not necessarily a feeling. Science can be described as art, but the creation of it is not necessarily artistic. It is very specific. We are always trying to, you'll see the word, measure things. And so when we measure things, we need two things. So, for example, Alex, when you are driving, for example, what is something that happens when you're driving, whether it's maybe you're driving with your grandmother and they are just like going very, very quickly to wherever they need to go, or maybe you're driving with, I don't know, a new student driver and they're trying to follow all the rules, go very, very carefully through the streets. But what is a measurement that we often are concerned about when it comes to driving? Whether it's the new student driver or the long-time driver, as they're kind of going through, as they're taking you to another destination, what is something that officers are always looking at? I want to make sure my iPad doesn't go too, let's see. And again, also the answer could be I don't know, or talk to me more, or give me like, and then again, this is just the delay, so I can have some ramen while we wait. Because again, what I'm trying to do is make sure we always start from things that most people know and work with and have a casual understanding of. Because I think if we can build off of that casual understanding, we might go something. Yeah, speed. Exactly. I think speed's up. And again, I will say this, one element of my teaching that can be a little meh is that sometimes I am looking for somewhat of a specific answer. But if I don't get that answer, I think we can find something. But yeah, speed. And so, all right, so we can think about the speed of a driver. You know, you might have an older driver who is going, let's say 40, and you might have a younger one who's like going 20. But notice how I said that there are always two things. There's always two things that we need to explain in measurement, right? This is not enough. If the older is going 40 and the younger is going 20, I have given you one of the two things, right? This number is one part, but the second part, right? This is kind of, again, if we're trying to do measurements, not only do we need the number, but of course, what else do we need? Not only when we say speed, but depending on where you're from, whether it's Europe and you use a reasonable unit system, I shouldn't say that, or if you're an American, you use probably a different unit system to describe these numbers. So what's missing here, if I can, again, kind of see if we have, I don't know exactly where this student is from and exactly what these numbers mean to them. They're not done yet. These numbers aren't finished yet. So what do I add to this? What is the second thing I need? And of course, the student knows in some level what I'm asking for, because they came in to ask about the very thing that we're about to basically say. But just settling us in so we know, we have a little bit more of a feeling for how these are useful in our everyday life. Sorry for the food ASMR. Because these numbers aren't enough, is what I'm trying to say. The numbers on the page, right? This number of 40 and 20 is meaningless. So with only the number, yeah, exactly, miles per hour or something similar. Now, I think what we often, so let's write this out. And so there's a very common term, miles per hour. Most people who are drivers, or most people who have driven with people, or for those Fast and the Furious fans, we know that this is a unit that we use a lot of time. And, I think what we want to then ask ourselves is, okay, what do each of these mean? And so for miles, this is a distance, right? There are many other ways we can describe these things. What are other ways you and I can share distance? Right? So, for example, me and Alex right now, I don't know where exactly Alex is, but I would probably use miles to describe how far away they are from me. I probably wouldn't use feet. I probably wouldn't use inches. But there are, and again, those are the American units. We don't see those in chemistry. We're going to use a base 10 SI system in chemistry, meters, for example, which then can go to kilometers or kilometers. But what I want to say is that in the phrase, I'm going 30 miles per hour, that is tied, the number is tied to the distance. And so they could have changed it to maybe instead of 30 miles per hour, they could have said some number and then the amount of feet that they were able to go in 1 hour, for example. But these are just distances. And there's lots of different ways we can share distances. And then what does the per mean? Well, the per, this is where we sometimes need to remind ourselves that this is actually a math word. This per means the thing coming after it is going underneath of the first unit. The number to describe this next thing, what comes after per, when I see per, the thing that comes underneath of it is going to be something that I'm dividing my first number from. And so when I hear per, I'm going to think of kind of a divide. I'm going to divide by miles is going to go on top and hour is going to go on bottom. So that's kind of important to know. And of course, hour is time. And there's lots of other ways we can talk about time. We can talk about seconds. Oops. Well, I'll just leave it, right? We can talk, this one's pretty simple. You can talk about seconds. You can talk about minutes. There's lots of things you can do. And so what I want us to pause for a second and feel fairly comfortable about is that we said, once one person might go 30 miles per hour, another person might go 50 miles per hour. But what if someone says, I'm going 7,000 feet per second? And this is where what you're likely struggling with in ECCP is. What happens when I have a distance, and a distance, but the units are different? And I have hour, and now seconds. And so again, the unit is different. And so what we want to ideally have is some simple way of converting these numbers from one thing to another thing to another thing. And what I'll do now is carefully bring up, just to make sure I don't show anything, I'm going to just block my screen just for a second. Okay. So scientists kind of felt like, yeah, we've got this interesting problem where how can I let's just say, for example, I am somebody who's interested in studying how fast like an animal moves. I'm interested in how fast a car moves. I'm interested in how fast a new boat moves. If I'm measuring speed of something, that's the scientist's job, right? The scientist is always going back to, I'm not going to explain things artfully. I'm not going to explain how things feel. I want to be able to measure something. I don't want to feel which car is faster. I don't want to feel these things. I want to know. But if I want to compare with another person, if they say my car goes 7,000 feet per second, and I say, okay, that's cool. My research says that my car goes 50 miles per hour. How do I compare these two? So we needed a way to convert units. We needed a way to all be on the same page about when we are researching things, when we're trying to answer the who, what, why of the universe, not with feeling, but with measurement. We all need to be on the same page. And so, America messed this up a little bit. Again, I love this country, but we messed it up a little bit because there are what are called SI units. So it's very rare, right, for us to ever be able to do this, where you can get a group of people in the room and all agree on something. But one thing that we kind of knew we had to do as scientists was we needed to set these quantities and make them universal so we could talk with each other. We could read each other's articles. Yeah, we might have to translate the language, but the numbers and the units, we should be able to compare our research to their research. And so this kind of, in some ways, like, humbles me a little bit, but there are only 7 SI base units. And so let's kind of look in on this just for a little bit. So, right, we already saw in miles per hour. In miles per hour, we had a length, a distance, and a time. And so when what we would ideally have, right, if I was talking with another chemist, let's move this over just a little bit. Really what they would like us to compare these to would be, let's do it in red. All right, they'd like to know some unit. What is this speed in meters per second? All right, that would be ideal because this is the way we've described, or how scientists would like to have a base way to communicate with each other. But again, everything you're going to see in this class, even when things get very, very complicated, and we talk about joules, for example. Let's look up joules for a second, because that's a very important part of chemistry, is the joule. And so if I look up the joule, what I'm going to find is the joule, at its very basic understanding, can always be brought back to base units. So the joule, which has a interesting description, it is a unit of energy, and it corresponds to, or 1 joule is equal to the amount of work done when a force of 1 Newton displaces a body through a distance of 1 meter in the direction of that force. And this might be a little bit above our pay grade, but what I want to say for today's discussion to remind us back is that we kind of started here and said, we know miles per hour. Most people understand miles per hour, but we want to be able to communicate with other people using the same units. So when we compare speeds, like how fast you're going, we're able to say, oh, that's too fast, slow down, so-and-so, or, oh, you could probably be going a little bit faster. If they're talking to you in feet per second or meters per second, it can be hard for us to decide if that's going fast enough or slow enough. And so in day-to-day talk, we use miles per hour. That's just what America has come to talk about when it comes to speed. But scientists would prefer to use some version of a meter per second, because those are the base units. The meter per second, that is you can describe anything that you can measure in the world, like speed, using a combination of these 7 units. And so in the chemistry world, we don't talk a lot about miles per hour or meters per second in chemistry. That's not really what we study. But one thing we do study is the joule, because we want chemistry to do stuff for us, and we want it to do work for us. We want it to happen spontaneously. There's lots of stuff we'll get into with these joules, but what we want to remind ourselves is that even the joule, even other things you're going to hear in chemistry, anytime you hear someone give you a number and a unit, they tell you something and some measurement, no matter how weird it sounds, like they say a Newton, or they say a joule, or they say something that you don't recognize at all, you have no basis for. You can always remind yourself that if you go to the Wikipedia page, you'll find that the base units say it has something to do with weight, distance, and time. Kilograms times meters squared times seconds to the -2. And that is really, really important for us to just quickly pause and do one more kind of math reminder, which is that when we see, not only when we see per, per, does that mean we're dividing by something? But if I have, for example, a exponent that is negative, that would mean that unit is also being treated with the per notation. It is going in what we call the denominator, the thing underneath the dividing sign. And so it becomes positive. It is just that it's underneath the dividing sign. That's what gives it the -2 when we don't have a divisor on it. And so right here, these are per second squared. So, okay, this is kind of interesting. So now let's actually do a unit conversion. So if we do want to say, well, these scientists don't want to necessarily discuss how fast you're going in miles per hour, but they want to compare it in meters per second. Well, let's take the 7,000 feet per, what did I say, per second, right? Yeah, per second. And so, great, let's kind of, let's just pause there. If you have kind of questions on what I've set up, I'm going to review it one more time, kind of let's even review it in a thing. So what I'm trying to say is that there are miles per hour, and you so miles per hour is a unit. You need a number to compare, let's say 60 miles per hour to meters per second. We have to, and this is going to be kind of where the lecture is going, we have to convert. And so scientists typically use SI units, and there are 7. Describe all others. And then those all others was just what this page was showing here. All right, this is really all you need to describe everything in the universe. Or that we believe, right? I'm sure we're wrong, but this is what we believe are the base units. So let me know if that feels good, and we'll move on. We'll kind of be, or we'll say, does that let us take something we know? Does it let us understand miles per hour? But if I wanted to compare miles per hour, if someone was like, well, that's pretty fast, but I'm going this many feet per second, how do we compare that? We have to be able to compare it, and that's where units and unit conversions come in. And so that's where we're going to go. We're going to see how fast is a 7,000 feet per second. First, we'll bring it to miles per hour, just so we get an understanding on a basic level of like how we might understand it. Then we'll bring it more to how the chemists might want it in base SI units. But we'll just see that units are kind of like a game in terms of once you know how to set up the game and you follow the rules of the game, units you can just basically say I can either hopelessly confuse people with how I describe something to them, how I describe a measurement to them. I can say something as like unhelpful as I was going a quadrillion nanometers per universal year in the lunar calendar. Like there are lots of units out there. Are they good units? Are they good measurements? You kind of have to ask about who your audience is. Does your audience understand what you're trying to communicate to them? And I think that's the most important thing we have for units. It's a way to communicate measurements. So it's like, how the heck do we get away from this? So just checking in with Alex, any questions or things that you're not sure about, because we would, I don't know what how much time you have to commit to this, because there are some times where you're just like, I kind of understand, let's keep moving forward. Or you might be more of the, let's, maybe you want to ask a question or firm something up before we go forward. Because where we're going to go next, right, this is where we're headed. None so far, great. So this is where we're headed. Again, a physical quantity, this is what we are measuring, something we can measure. Length, mass, time, electric current. Let's go back. Length, mass, time, electric current. So dimensional analysis is the analysis of the relationship between these physical quantities, miles per hour, by identifying their base quantities and units of measurements and tracking these dimensions as calculations or comparisons are performed. So remind yourself again that there is a quantity, there is a amount, there is 7,000 of what? 7,000 feet. It is a length. I'm describing a length that I'm going, and I'm describing it in feet. I'm not doing it in meters yet. So the question I have to ask myself is, and maybe even before I do this, can I ask the student here, how many inches are in a foot? How many inches are in a foot? Before we try to make, like, let's I'm going to assume you're more in the American, or I'm making the assumption that who I'm talking with is more comfortable with the SI, or sorry, is more comfortable with the American measurement. So how and if they're not, let me know. But how many inches are in a foot? That might be something you remember. You might not remember. But how many inches are in a foot? 12. Great. So what would you expect then, approximately, if I have 7,000 feet? How many inches would that be? Would it be that number, but 10 times its size? Or maybe it would only be half this size? Can you give me an estimate? We're not looking for exact here. But do you have a feeling for if 1 foot is 12 inches and you have 7,000 feet, if I tell you this number in inches, will it go up or will it go down? Will the distance is the same, but how I describe it to you, will that number go up or will it go down? And let's write down what you know. Right, you know that a foot, 1 foot is equal to, and again, don't worry if you're wrong. I do not care if you're wrong. Like you should be wrong some of the time, or at least I'll try to tell you if I think you're wrong. It is more than fine not to know the answer, but would you expect when I describe this, if we know a foot is 12 inches, the number goes up? Yes, it does. And so how does that happen mathematically? How can we arrange a system that we don't have to like pause and think about it, but it just works for us? And so that's where dimensional analysis comes in. So as I kind of go down a little bit, we're going to say that we what is this technically called? I don't know if I've ever seen a technical term for it. This is what I love about science. It's like, oh, you want to learn about units? Here's like the most confusing possibly to new students, like way to understand it. And then look at all of this stuff you can go through about all of the it's just units, guys, but I love it. I love how I don't see what I'm looking for here. So anyways, let's walk away from this for a second. But I call this a lattice. All it is you're kind of just setting up a tic-tac-toe extended pattern. But what I want you to know, awesome, hey, we got somebody here. Hi, Bella. So Bella, I'm going to finish this mini lecture with Alex. I'm pretty close to being done, or at least in terms of being done, in terms of giving my initial before we maybe work a problem the student has. But I'm going to finish this, Bella, and then I'll come to you. Bella, if you don't have time to stay, you're just stopping by the office real quick, always feel free to post your question to Canvas. I will update the Q&A on the web page. You may need to refresh the web page or like clear your cookies. I'm sure there's something weird we're going to have to figure out with that. But yeah, put it there so other students can see it, or stick around if you have a chemistry question. That's kind of part of what this space is for, but I'll chat with you in just a second. So we need to go back to handling how do we organize units. And so what I want to remind you is that on this lattice, right, there are these up areas, things you could put in here I'm considering up, and things I'm considering down here I'm going to consider kind of the down area. So we're going to organize this conversion. You know the number's going to go up. You know this 7,000 feet per second, when it goes to inches, the number's going to go up. But how do we do it? How do we organize it? And so it's using this. We have this kind of lattice, this tic-tac-toe setup. There's this up area, there's this down area. So let's convert this now to using it. And so I have a lattice. And so I'm going to think to myself, I have the phrase, let's make sure I get the right one. Was it 4,000? 7,000. So we have this 7,000 feet. And then it says per, and it doesn't say this, but, and this can sometimes mess with students. Actually, that kind of is even more confusing. But notice how when you just are casually talking to someone about miles per hour, you don't say I'm going 30 miles per 1 hour. It's assumed. But if we forget that these units, every unit must have a number associated with it. It's not that I'm like, hey, how fast are you going? I'm going miles per hour fast. No, we say a number. Same thing with the 30 miles per 1 hour is really what we should be saying, but it is assumed. And so in the above, I'm going to put the number and I'm going to put the unit. So in this up section, I always put a number and then I put a unit. And because this is the per, because this means I am going to divide, it goes below. And so I'm going 1 second. Once again, I have my number and my unit. So let's briefly let our eyes kind of go back and see. There is this up area for things that are not per. They don't have exponents with a negative in them. These are positive exponents. Another way to write this would be 7,000 feet to the power of 1 times 1 second to the power of -1. It's that -1 that makes me know when I'm setting this up, it goes into the bottom of the lattice. And so I go down here for a second and say, okay, great. I understand this, so let's kind of now do the problem. So let's say I have 7,000 feet per second, convert to inches per second and meters per second. And so the problem would say, or I would set it up where I'd say 7,000 feet over 1 second. And now again, we kind of have to come back to something about math that either we like or we don't like, where it's that when we have a number, so let's kind of focus ourselves over here. When we have the same number over the same number, they cancel out to 1. 5 over 5 is 1, 10 over 10 is 1, 5 over 5 is 1. And the units as well, if this was 5 feet over 5 feet, 5 feet per 5 feet, we would have those cancel out as well. 5 over 5 is 1. Feet over feet cancels out to 1. And so what we want to do here is say, we just discussed that 1 foot in the denominator, so there's my two things. I put my number and I put my unit. Right? There's always two things. You have to always remember there's two things. Units get lost by students, but they're super important to remember that they guide you. There should never be a quantity that doesn't have a unit associated with it. 1 foot, and how much is 1 foot? Well, in 1 foot, there are 12 inches. I am purposely putting it so that, let's focus our attention, I'm purposely putting it so that my foot unit and my foot unit, these will cancel out. And so after I do my units, if I take my yellow, I say, okay, we don't have feet anymore, but now whatever I'm going to get, the units are going to be inches per second. And so when I go back to thinking about this not as a lattice, not as a form of organization, but how is it doing math? Well, it's basically just 7,000 feet over 1 second times 12 inches over 1 foot equals, and so I'll do that, 7,000 times 12. There we go, 84,000. And once again, we're like, well, how useful is this? Well, let's convert it to miles per hour just for fun. And remind ourselves too that it doesn't matter where we start from. We will always get the same answer. And so I'll start just again from, we have this 7,000 feet per 1 second. Put it in the lattice. I need something that will go from feet, and I need to know how many feet are in a mile. And so I'm going to look up that relationship. How many feet are in a mile? 5,280. So there are 5,280 of those little foot measurements in every 1 mile. And again, you can ask yourself, will this number that I'm going to calculate be bigger or smaller? Right? And we're asking these things just to have a, oh, you can't see it, sorry. You're asking yourself, if I'm working with units that I have an understanding of, which won't always be the case, we can make some guesses about, well, this has to be through division. This has to be through multiplication. And in this one, we kind of know that a mile is bigger than a foot. So when we convert from feet to miles, when we're trying to talk to someone about how fast our car is, and they're like, I don't want feet per second, I want miles per hour, we'll say, well, first thing I can do is convert your feet. And the second thing I can do as well, like let's even extend this just to show how useful a lattice is. These lattices can be chained together to do multiple conversions at once. So I'll have 7,000, here's my unit, feet per every 1, here's my unit, second. And so the first thing I did is I said, let's actually do different colors. And so I know that there are 5,000, ooh, I don't like that. There are 5,280 feet in, oh, here's our new one. I'll put the unit first. In 1 mile. And I have now, okay, let me ask you, either Alex or Bella, if you want to jump into this conversation, anybody can jump in at any time. Of course, if someone is going through something a little bit quickly and you didn't quite process it, you can always pause the video and think about it before you hear the answer. But what is the conversion of seconds to hours? Use Google if you want, or let's do this instead. That's kind of hard. I don't think people know how many seconds are in an hour, but do you know how many seconds are in a minute? Does anybody know how many seconds there are in a minute? iPad go out. Stay with me, iPad, please. Right, I'll just do this one because I know that the response time I don't think is as fast as I'd like it. 60. Yep, great, awesome, guys. So we basically will say that, but watch carefully when I use this lattice. Watch carefully how I got to be very, very specific about where my two things go: the number I'm conferring to someone and the unit that gives the number meaning. And so the unit here actually on top, right? I don't want seconds at the end. So if I want seconds to cancel out, if I have a second in the denominator, the bottom part of the lattice, the dividing area of the lattice, the negative exponent area of the lattice, to get rid of it, my converting factor, my 60 seconds to 1 minute goes 60 seconds. Now my units are on one's on the top, one's on the bottom. 60 seconds for every one. Here we go. We got a new unit. 1 minute. Now we can do something that I know. How many minutes are in a... Sure. Let's do pink. How many minutes are in an hour? There are 60 minutes in 1 hour. So now you've noticed the beauty of, or maybe you haven't noticed it yet, but I've definitely noticed this is a really helpful way for me to say anytime someone gives me a number and they attach a word to it that tells me what that number means, joules, newtons, meters, seconds, meters squared per second squared, times, I don't know, lots of crazy stuff. You can always say, I know there's base units here somewhere. Now, yeah, ideally you'd have access to your cell phone and you could do everything I did here about looking up some of these converting factors. But in previous times when we didn't have the internet this accessible, either you tattooed it to yourself or you memorized it. But let's go through this and first deal with our units. What happens to our units? And so my feet are on opposite sides. 1 up, 1 down, goes away. 1 up, 1 down, goes away. 1 up, 1 down, goes away. So whatever I'm going to tell someone, the answer is going to be miles per hour. That is the result of the unit. So now we're going to know how fast the heck is this car going. So for me, I look at this, and let's go to another great resource. Wolfram Alpha. So again, I want you to kind of hopefully see in this stream how I convert this picture. This is the art, right? I told you, chemistry will test you. This is a very simple art, but there is a style to it. There is a pattern to it. There is things that the viewer knows about it when you're conveying this image to another person. But there's also math behind it. So what it is it is 7,000 divided by 1. That's the first lattice, times here's my next lattice, in parentheses. 1 is the number on top, the number on bottom is 5,280. Okay, that's my next part of the lattice. Then it is a 60 over a 1 times a 60 over a 1. And let's equal that out. So you can see in the input, it kind of looks like how my lattice is set up. And wow, that's pretty cool. We're going pretty fast. So this is an amazing piece of machinery. So we have, what is it, about 4,700. And so it's going very, very, very fast. And so I just want to remind you that the tricky part with all of this work is that you are going to come across units that you are going to want to Google, find their Wikipedia page, and get an idea what their base units are, because this is a game. It's about converting the right things, multiplying the right things, and getting them from one to the other. The last thing I want to leave you with is another cute thing. This is why the metric system is better than the USA system, right? If I have 1 meter and I want to convert that to 1 meter to 1 kilometer, this is kind of similar to what we saw before, where for us, we would say we're kind of used to 5,280 feet is 1 mile. But what we don't like about the US system necessarily is that this is a number going to this number, but check this out. 1 meter to, or let's say how many meters in a kilometer. The nice thing about the SI system is it is 1,000 meters in 1 kilometer. Notice how this is a base 10 thing, and you might be asking yourself, does this work in a lattice? Yes, it does. So if I have, let's say, 6 meters, and I know it's 1,000 meters in 1 kilometer, right, you can see that there's the units. They're going to cancel out, and I can move a number so it has a same unit of description, but its prefix, the thing before it, kilo, means 1,000 times the base unit. Pico is much smaller, but always a base 10. So I'm going to leave that there for now. Alex will come back to if you have a question or a clarification, but Bella, go ahead with your question, and I'm going to just update the Canvas page to say that we pause just for a second. So let's check our timing. We are at hour 23. Okay, that's saved. So yep, go ahead, Bella, shoot your question when you can if you're around. And if not, we'll kind of go back to seeing how Alex felt about that very, very rushed discussion of units. But I think if we do some problems and I ask you for help with it, having you think about it and do it. Hey, I just want to clarify things. Great, go for it. I was trying to figure out where to find the homework and the pre-class work. I saw under the class 2 module that we have some pre-class work. I assume that would be the first thing that should be done before class. Let's go ahead and look at that just a second. I'm just going to mute this just for a little bit. I'm just going to make sure I don't show any student names. Let's view it as a student would. Okay, great. I think this looks good. Okay. All right, so basically, anytime you come to a class, the thing I want to draw everybody's attention to is the learning objectives. These are the most important things to feel comfortable about because this is how test questions are built, or off of learning objectives. And so, no, it's not like the easiest way to tell you how to study, but it's certainly every question we ask should be tied back to us testing to see if you learned learning objective. And then you're right. There are these before class things that are given in the base class, and I want to get better at explaining it to students, but what I would say is that what my goal is as your teacher is to not limit your resources, and so I am more than fine with whatever Emory kind of has in their base Chem 150 course. I'm going to publish all of it. I'm going to leave all of it up. I'm not going to go through and get rid of anything. If it's there for a reason. However, is every single thing on here necessarily important for every single student? No. The Power of Tens, really cool video, but it's more about giving students an understanding of how the number and the unit, as you change those descriptors, the world, as you come out and out further and further and further, how we describe different distances and getting a feeling for how big things are. But is it particularly important? A little bit, but I'm not like not necessarily a necessity, and so I'm going to leave it all up there. What I would say is pre-class work is important to do, and it will lead to a better lecture experience. If there's anything that they're giving us for pre-work, I would recommend you find a way to schedule it into your system. But there is no obvious way for me to, or there's no obvious way I'm going to be checking it. Your grade is not going to be obviously affected by did you do it before class or not. Something about paying $45 for something in class. Is that active? Yeah, I'm pretty sure it is. So I think active chemistry, Emory, and I still have not gotten into that system. That's something I'd like to do later today, or I'll do it later or whatever, but this is not what I want. Yep, so right here, there is a chemistry.emory.edu/undergraduate/ECCP, tells you what it is, how to get to it, and on the Canvas site, I just don't want to show anybody's name, so let me make sure I get to the right thing before I show you. Great, okay. Going back to showing you what I have. As well on Canvas, there is the page Resources, Grad TA, Office Hours, Learning Assistance, Tutoring, Financial Support. There is if purchasing the subscription to Active, please fill out the Student of Conform or Student of Concern form. And then here's the rest of the information. There's a grace period that extends until September 22 to use it without a paid subscription. So you can get working on it right now. But yeah, I hope that helps. Let's see. Yeah, so I think what I want to go back to reminding ourselves is, can I get here without too much issue? Yeah, I think I can. I just go to here. So let's go here, let's go here, let's go here. We're in general chemistry. Does it show? No. Okay. Not now. Oh, I should be a little careful. There are some things on here that are touch sensitive. Let's get to the right one. Okay, this does not look too bad. Yeah, so really it is about your midterms, that'll all be handled, but the Canvas quiz, so it's like, I would say the important dates to have in your calendar or your syllabus is that Monday nights you're going to be looking for homework that you've had a week to do. There are 4 dates you're going to look for a Canvas quiz that you have 27 hours to repeat, or you have 27 hours to do, and then you need to finish this ECCP by September 10. That's all you really need in terms of if you're looking for like homework or things that will affect your grade, it's these things. The pre-class work, the practice worksheets, everything else practice. I'm giving you these resources, but I'm not going to make it busy work for you in terms of I'm not going to force everyone to do it and then force me to grade all of them. But that is, you're going to need active because there is a part of your grade. How much of your grade is it? 13% of your grade is through active. So that's a big thing to get going. Canvas quiz will happen later. We don't have to stress about that too much. We'll explain that later. But you already should know about Canvas if you're seeing the pre-work. But yeah, so let's see if that answers it. Okay, yeah. Is my homework, or will there ever be homework on my homepage? Possibly in the future, but for this class, no. With an asterisk. I am doing what I always do, which is like think about things that will probably be too much work and I'll end up not really doing what I want. But I am thinking about my class website might have something on it that serves as a replacement or a way to upgrade this score. So let's say we are the worst class, like we fail every exam collectively. We don't get any of this 3% I've proposed. I'm thinking about something else where I might have this opt-in. If you want to work on some stuff I create throughout the semester, you can maybe get a bump to this outside of your classmates based on how well you do. So, but we'll talk about that more on Wednesday if I do it. But let me see what else there is. But right now, I'd say go to my website if you want to get what Cam thinks is good, valuable. It's where I'm going to collect what I think is really, really cool. Lots of different places. I'll definitely steal from Emory when I can, but I'll also add things that I find interesting. I'll add my own work. It'll grow over time. And so right now it isn't very full, but each class day I'll at least go through the internet quick and fill it with things that I think are helpful. So it's worth checking it. Will things on the ECCP also be reviewed? I'm not sure what you... Oh, are you saying on class, are we going to review ECCP? Probably not. I think if I'm going to review anything on ECCP, it's going to happen in this space or in Discord. But the ECCP stuff is pretty important to... Or I'm still trying to get access to the ECCP. I know about it in Alex. I know some things that are covered in it, but once I get at my own access to the active site, I'll have a better idea of what the heck is going on with all of that stuff. Or at least where are students struggling. And maybe I'll talk 1 or 2 questions in class about it. But my goal is always going to be trying to bring it back to something you know. Today with units, we talked about miles per hour. We tried to use miles per hour and the number we use in front of it, 60 miles per hour, 1,000 miles per hour, 1 mile per hour. We tried to understand what that means to us in this world and then start walking to where a scientist uses base SI units, meters per second, not miles per hour. And we use it to compare things. We use it to explain to another person how good or how bad our experiments were. We also just use it to describe science itself. Like everything we're going to talk about was measured in some form. And so that measurement should at the very end of the day be baked back to an SI unit. So let's put this down. Let's put that down. So I will leave that there for now. Any other questions on units? And thank you guys for coming. Like seriously, I really appreciate chatting chemistry with you guys. This is my favorite part of my job. And also let me know too, anybody who was watching, was there anything that helped with my unit lecture? Is there anything you're still questioning or want me to talk about? Or do you want to talk about how you understand units? If you want to type how you understand units, it's really good for you yourself to try to, in your own head, verbalize and then write down what is your understanding of units for me to look at and read and either agree with or put apart. It's a specific one from ECCP. Like I have an idea for how to do it. Oh, cool. Okay. Yeah, I'm happy to. Yeah, absolutely. So let's do this. Go ahead and stay where you are for now, and I'm going to create a Google document. Okay, so let's create a Google Doc. Or would a Google Doc be good, or would slides would probably be better? Let's try slides. Bow, 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 bow. Bum 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 ba-dum dum bum 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 bum. Okay, copying link. I'm not sure if I can actually do links. Maybe if I'm the YouTuber, I can. Okay, let's see if I can. I think I can. So let's see. You should be able to click that. I think I can even pin it. Okay, great. And so what I'm going to ask you to do is And what is it called on Mac? I think it's just called screenshot. Okay, so we got a bunch of them. So yeah, if you have a question, because I think, Alex, tell me if I'm wrong. You're saying, will things on ECCP also be reviewed here in Office? Absolutely. In fact, let me get back up what we're doing. And so again, in here we should just have anonymous stuff. Yep, great. And if we need internet, we have it there. I'm assuming you have an ECCP question, so if you're able to screenshot it, I use what's called a snipping tool, and it snips it. I often save it in a, or you can even take a picture with your phone if you want and upload it. Just be aware whatever you put in here could be seen by other people and is recorded for all time, so just consider what's in your picture or things like that. But yeah, I'd be happy to go over a question. And let me know if I'm getting what you're saying wrong, Alex. But this will just let us kind of share things that we want to talk about real quickly. And what about the student? What did the students? Did I answer the student question? Yeah, I kind of did. Nice. Yes. Thank you. Okay. Great. Awesome. 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 Yes. Great. Okay. Ooh, this is interesting. Okay. So first, let me say this. What I really like about this is that they are doing what I'm doing. They're saying blue is the quantity, red is the unit, and so we have a starting amount. And you can see that they haven't maybe done the best job of showing us the lattice in it. But let me come in here then with a text box. And I'll say, great. So go ahead, I'm going to make a new text box. So what goes here? What goes in the starting amount? So this is the red thing. This is not a quantity, but this is a unit. And so what are we starting with? And go ahead and edit it for me in real time. And so let's do my text kind of in maybe, how do I want my text to look? Does that read kind of well? Kind of. So let's start here. What is our, and, right, look here. We have, yeah, nice. Because this red box is reminding us we need 2 parts to any measurement. And so the red box is unit always. Well, maybe I shouldn't say always, but it looks to be this way. Like when we're dealing with this, yep, I 100% agree. So let's just say, cool. What is the amount of centimeters? And this number is a little tricky, but we would say that there is now in blue, there is what goes here. And we want to remind ourselves too, as they're working on that and filling that up. Let's kind of push that off to the side, bring this back up. Nice. Yeah, love it. Love it, love it, love it. Great. So now we have the 2 things we need. We have this and this. Just remind yourselves whenever you see this, what is 10 to the -8? It doesn't show us particularly well. Is there a way I can get it to show? Not quite what I'd want. But it's a very, very small number. It's like a 0.000001 number. So this is a very, very small amount of centimeters. But what is its distance in nanometers? So now we're going to do the tricky part. Now we're going to do where I want it to help you learn a little bit. So we'll say, okay, now we need to use the lattice, what I kind of said, the up and down. And so let's get rid of this. Let's pull this. How do I want to do it? We'll leave it like that. And so let me re-share my iPad a second. And let's grab a timestamp. This is now hour 43. Okay, on unit conversion. All right. So again, if we kind of remind ourselves what I said about how there's this up and the down section, and what became kind of interesting about this up and the down section is this here to go from, let's go back to this feet to inches idea. I needed the feet to go away, so the feet unit went underneath. So before we put in numbers into here, what we want to ask ourselves is, okay, we have potentially 2 places to put the centimeter. Do we put it here? Or here? Because our answer is going to not be in centimeters. So we want to get rid of centimeters. So delete one of these. Where does, or I'll say this. I like to do units first, numbers second. Where does centimeter go? Delete the one that you do not need. So we want to leave one of these boxes here because we always kind of look backwards to go forward. So yes, great. We looked backwards and says centimeter is on top. And so, yeah. Yes, so they cancel out. So yeah, exactly. So centimeters here. But what are we going to, and can we go there right away? Can we find a number for the relationship of centimeters to nanometers? And so that's a Google. That's a centimeters to, oh, wait, I don't want to go too far. So if that's there, we know then that the final answer we want is going to be a nanometer. So that one goes up top. Now we just need our conversion. So centimeters to nanometers. It says 1 centimeter is 1 to the 7 nanometers. What the heck does that mean? 1 to the 7 meaning? We may be confused about that. Let's see if it can show us as a... Yeah, okay, cool. So look at that. 1 to the 7 is a really, really big number. It also is represented as this E is a times 10 to the. And so we'll go back to our thing here and say, okay, we've got these big, big numbers, but we need to find out that there is 1 centimeter. So there is, I'm going a little fast, 1 centimeter. So I'm going to connect the number to there. There's the number 1. And then it tells me how many nanometers, 1 to the 7 nanometers, 1 to the 7. But if I don't like that, or if it confuses me a little bit, there are other ways to write it, these ways as well. And now I have a calculation. And so let's keep this kind of over there. Let's bring this over here. And now we go to Wolfram Alpha again. And we say, okay, our first lattice is 1.21 to the negative 8 divided by 1 centimeter. or no, not, no, it doesn't have anything it's dividing by. It's just this number, so it's just centimeters times, in this lattice, we have 1e to the 7 divided by 1 centimeter. And so we'll make that answer. And then let's just make sure, let's check that it interpreted my input correctly. This is an important thing to make sure that the computer is listening to me correctly. So let's see, 1.21 times 10 to the negative 8. That is what I wanted. And I want to times it by my lattice, where I have a big number because there's a lot of nanometers in 1 centimeter. So that all looks right. My result is 0.121. And so you should be able to, let's see if we can find that answer. Yep, I see it somewhere in there. So that is how I would approach that question. Does that help a little bit? And let's see, where did I end this? Let's find the ending was 148. You know, or why am I typing it here? You know, it is, you know, you want to get comfortable with your calculator, how to do these exponents. That's really, I think, the next thing that we always have to deal with. Awesome. Cool. Well, I will leave this screen as something I can always come back and using. But yeah, keep throwing questions. If not, I'm going to get back to inviting people into our Discord. So for that, I'm going to just hide this. But I am still around. I'm sure there was an easier way to do this that Tuan could help me with, but so it is. It's so messy, but it'll have to work. Oh, I should put up the cute little, I'm here, but not here. I'm here. I think it's this one. Yeesh. Nice. Okay, let's post that. I got a level 2! Don't know what that means, but I freaking love it. Alright, back to how the heck do I? I've invited people. Now, how do I? Maybe it's here? Oh, cute. This is so cool! Okay. Could put my ramen away. Maybe I should be doing it on here? My man. My freaking man.
Did that work?
Oh, I see.
Elbow.
Wow.
You were vaping? So you're gonna have new withdrawals again when you finish that one?
I didn't even experience that bad withdrawals.
Denial.
True.
Is that the same one or did you go on a landmark?
Good question. Same one. Again, I'm gonna be going off to get medication at 5. All right. Here we go. Go back, and I think it's this one. Anything showing? No. Awesome. All right, we're back. I think we're clean. Okay. And let's go to here. Okay, so this we can show. Okay. Because we kind of want like a general syllabus. Does this even work anymore? I don't know if that does. Let's see. What was that called? Oh, we have a question. We have a question. 1 second, guys. I'll be there. Got what I need. Hey, I'm in your Chem 150 class and am struggling a little bit with the ECC assignment. I was wondering if you were on campus for in-person office hours right now. Not right now, but I can happily help right now. Let me even see just for a second. We do have, if you go earlier in this video, so if you look down and go back on the video, we have a discussion about units. I think you can go to it, can you? Yeah. There's a discussion that I do have on units. If you kind of go through it, you'll see where I bring up my iPad, talk to students. If that helps a little bit, we can do it there. As well as what you're going to see, hopefully, there should be a link above that if you, let me check. Go here, go here. All right here. Okay. If you're able to take a picture with your phone, or if you know how to screenshot, I'm going to post this link again in our chat. But if you have a particular question you want to go over, we can post it here at this Google Doc. Let me show you what I can see on my end. Yep, I think we're still good. Yep. So basically, if you post a screenshot here, I can go over a question that you might have, but it also might help to go look at the other video. I don't know if you're even seeing this right now, but feel free to post it here. I'll keep an eye on that. I'm just going to keep working on this syllabus as we kind of chat. Because, again, let me just make it like whether, or I'll even type it. Okay. All right, so we're going back to figure out if we have our voice thing figured out. I think it was on here. Oh, I forgot. It's the different password. Oh, no. All right, I'm going to be locked out for a little bit. Okay. Good. Let's just say understand chemistry at a deeper level. I uploaded the question. Thank you. Awesome. Nice. Great. Yes, great, awesome, good question. Okay, so what I'll do, awesome. Okay. So this student has posted a question here, and I'm gonna just crop it just a little bit because they're doing everything that they need to be doing. But let's kind of grab some stuff from here. So where I want to start with is let's just take this and say. So I'll put my thing up here. So all measurements are given in two parts. There's always a number. I'm going 90 what? I'm going 90 feet per second, 90 feet per minute, 90 meters per year. I'm going some whatever. And so we have another thing being described here, some feet cubed going to minute or per minute. Some sort of 210 feet cubed things are going per minute. And so what I want us to look at first is what is the unit that we have to start. And also I want to make a quick timestamp. So this is 241. 241. Is that right? 241. Oh, 241. Because this one, I like this one because it's a little bit more tricky of a question. So, okay, back to this. So what is the units that we start with? There's the number 210, but there is this unit. So what are the units that we're starting with? And so we'll try to see if I can have this student kind of help me a little bit. And again, they may need to review the earlier part of the video, but I want to, yeah, if you do, just let me know. Just say, hey, I'm going to go back and review the earlier part of the video. You can scroll back and see when I pull up an iPad, come back and talk about this. But I'll try to get it answered before we stop at 5. So I'll say, kind of want something here. Let's leave it as red. This is something I type, so let's leave it as green. Because, well, yeah, I'll pause. Yeah, it is. Great. So go ahead. Awesome. Yeah, I agree. Because we have some issues that we're going to want to deal with. So it's like, well, this is going to be, we got to put something here. And ask me questions too. Feel free to type a question. Not necessary. You know what? Let's leave it. Kind of leave this off to the side. Yep, great. I see it. Awesome. So they put it in? Great. Nice. Okay. So we need to see this in lattice form. So let's pull up my iPad a second. Okay. So we have a unit of feet cubed. So I'm going to put feet cubed. And then underneath of it is, well, let's have a quick discussion too. When I have feet cubed over a, let's use better color coding. So I have foot cubed divided by minute. So the first thing I want to show you is that on my, there needs to be some exponent here. Whether we put it or not, there is one. And so in this case, there is the exponent, as written, it would be to the power of 1. But another way we can write this is equal to feet cubed times and so notice how the negative so right, we have this minute -1, which means it really belongs underneath. So that can be a little tricky. Oh, I'm not showing it. The negative value here, so we have feet cubed per minute to the power of 1. This is the same as feet cubed instead of a dividing sign, but a times sign, the minute, but the exponent is now -1. When I have this negative, it tells us we put it in the other part of the division sign. If it's in the numerator and it's negative, it has us go to the denominator. And just as a reminder, this is the numerator, this is the denominator. Right? When I think about on the division, there is the top and there's the bottom. And so the -1 says put it down to the bottom, put it in the dividing sign, and now the negative goes away. So that's kind of important for us to see because it'll help us set up our lattice, because now I can kind of come back and say, great. So my student was able to identify that the unit to start is, let's go back to our colors. We have feet cubed 2, and underneath we have minute. And so the value is, let's go back here and say, okay, so you have shown me what the unit is. This is nice. What is the second part of this calculation? There should be a blue. So when I tell you I'm going miles per hour, that doesn't mean anything. If I just say I'm going in red miles per hour, here it's feet cubed over a minute, whatever the heck that means, whether we know what that means or not, or have a feeling for what that means or not. It's about a volume, it looks like, that's being moved over time. But what it goes in the blue question marks. I'm not just going miles per hour, I'm going 60 miles per hour. So we need something in these blue question marks now. And then we'll go back to our iPad. So now it's like, it's not miles per hour. We know how much it is. It is 210 feet cubed per minute. Now, we do not want our answer in feet cubed. So when I want to get rid of a unit, I extend my lattice and I say, well, we're going to need to get rid of the feet cubed. So now they will cancel out. So I've extended my lattice and said, the thing I don't want in my answer, I don't want this in my answer, so I need to put it first. It's in the numerator. It's on top of the lattice. This is what I call the top section of the lattice. Let's do it in black. Right, these are the top area, and this is the bottom area. And so when I have the top area, the numerator has feet cubed. To get rid of it, I put it in the bottom. Now, if I can ask the student again, if I want to get rid of feet cubed, what do I want at the top? What do I want here? Looking at the answer, what does the top part of their answer want? How can I explain this better? They have told us where we need to go. This person we're talking to, we went up to this person and said, hey, I've got a really nice vacuum. This vacuum can clean everything. And it has 210 feet cubed per minute pull rate. And they're like, I don't know what that pull rate means. Can you tell it to me in liters per second? What do they want in terms of, they don't want feet cubed. What unit do they want? And that will help me decide what goes in this black box. And go ahead and type it into the chat if you want. I'll put it here. We're telling someone, hey, I've got this awesome vacuum, 200 feet cubed per minute, and they're like, no, I want it in liters per second. And so first we're going to deal with the feet cubed part. This is some description of, it is liters, thank you. And just for anybody watching this later, you have to ask yourself, what does feet cubed mean? Feet cubed is describing a volume. This is a XYZ of something. My cell phone, for example, has a height to it, it has a length to it, and it has a width to it. Those are three things I could measure. How much is this in feet? How much is this in feet? How much is this in feet? And with those three measurements of length, I can describe a volume. So 3 lengths together is a volume. Liter is a volume. You have probably purchased or seen at a party a 2 liter of soda. That is a volume. And so we do need feet. And so the next unit we need is a liter. And so we're going to go to our internet and say, how many liters in a foot cubed? And it is 28.31685 liters would be able to fill a cubic foot. And so we're going to say that, let's copy these units exactly. So I see the number 1 cubic foot, 1 foot to 3, is equal to 28.31685 liters. So now I can see that it's a game. It's really like, maybe Sudoku's not the right way to say it, but it's like, okay, that cancels, and now I've got liters. I've got one part of my answer. I've got the liters on top. It's on top. Now we got to deal with what's on bottom. And so to get rid of that, I'm going to say, to get rid of a minute in the bottom, to get rid of a minute in the denominator, I need a minute in the numerator. And what do they want? They want to know, they understand vacuum measurements in liters per second. So how many, let's do a new unit. So we're going to see, do you know how many minutes are in a second, or do you know how many seconds are in a minute? Let me know in the chat. And so one of these both works, right? I can tell you how many minutes are in a second, or I can tell you how many seconds are in a minute. Both work, but one is more commonly talked about between people. And it's totally fine if you're not sure, if you have some questions about all this stuff. This is exactly what we want to be doing. And you can even Google it, right? Now, granted, on the exam, that's going to be less of a possibility, but take a second and look at that. Here, come here. You can say hi to him.
Come on, say hi.
60, yep, great. So that is a converting factor. You can tell me how many minutes it's going to take for you to do the test or a question on the test, or you can tell me how many seconds it's going to take you to do a part of the test. You can even tell me how many parts of an hour it's going to take for you to do a part of the test. All those are times. So you're just telling me, and I agree with you, there are 60 seconds in 1 minute. Once again, I can look and say, okay, now minutes are in top, minutes are in bottom, they go away. So I have now, at the very end, what hasn't canceled out is I'm going to be given I'm going to be given an answer in liters per second, which is what the question wanted. They wanted liters per second. And so when we look at your options, all right, let me copy this a second. Oh, I gotta undo it. Oh, crap. I might have lost it. Maybe I can undo it. Sorry about this. I gotta get it out of I put it in the background, which I thought was a good idea. And it was a good idea until... okay. Let's make another one. There we go. Set it back as the background. Great. Paste this a couple of times. And so when I look at your bank of things to choose from, it is a game. It's just a game of like, well, how does the person think about units? Do they use the same units as me as not? They don't in this case. So the first thing we wanted to do is say, what is our starting unit? We're given it in feet per minute. So that definitely goes there. Then as we crop this one, we say what amount of it. Well, there's this much. This is how good the vacuum is. And so what I'm doing here is I'm cropping the image. I'm choosing that I need to have something that converts let's grab. So let's see, which one of these do we need? Well, we need to get rid of feet cubed, but I want my feet cubed to go to... Let's get this out of here. So they're kind of asking us again what we saw over here. We're trying to put in a similar kind of descriptor of it. And so let's say... Allie was looking for Bilbo and thought that I had lost him. So, okay, great. We're kind of still thinking to ourselves, okay, we know what some of these conversions are. We have these feet, or these liters per feet. And Let's see a second. So we have a liter. Oops. I think this is what they want. And so we'll put this one there. Let's make it a little smaller. Do I like this? I have a little bit of a disagreement with how active is showing it, but I think what they want from us is to put the liter on top, put the second on bottom, and then the amount of the number that we then put in how many liters? 28 point. Okay, so they don't have this conversion factor either. Okay, so we're going to have to, so they're doing it a slightly different way. So we're going to have to even more play their game. So I'll pause for a second and say, this is how I would answer it. This does give us the answer, but they want us to do something else. So let's see what we can do with what they've given us. So we have feet cubed per minute, which I wonder if we could do that to that. So if we know... Let's take then instead their unit of... So again, what do we want to get rid of? None of this unit ends up in our final answer. So if I don't want anything to do with feet per minute cubed, I'm going to put this in the opposite location of the divisor, or in this case, what I'm kind of describing as a lattice. There's this top part. There is the top part up here. This is the numerator. Bottom part is the denominator. And so I'm kind of thinking, well, I want my feet cubed per minute to go away. And what I want on top instead is liters per second to come out. And so now we need to figure out if we have these converting factors of feet cubed per minute and liters per second. Now the question is, what is the actual number that correctly quantifies these things for us? And I would say that the feet per minute that we have in this case is 1 feet per minute, because that is what I'm trying to find the conversion of. You'll notice going back to my I want to remind students that this is kind of tricky, because this question, I love that because I like what they're doing in some ways, because they're asking us to do they're taking the lattice and combining it together to say we can simplify the lattice. It may not be the easiest for us to learn, but we can do it. So we're still trying to think 1 feet per minute. That is still in here. I have my feet and my minute, whether it's on top or on bottom. This is, again, let me show you how tricky this is. So I want to show you how what I've done is still connected to what we see here. We have in active 200 feet cubed per 1 minute, and they're asking us to put we're going to put a foot cubed and a minute up here. And we're going to say this is 1-to-1. 1 foot cubed is equal to this 1 minute. or this is the, I'm trying to explain the denominator in the active answer. What happens when we put feet cubed per minute in the denominator? It puts our feet cubed onto the bottom. And so this is a bit of a math review for us. When we have 1 over feet cubed, or sorry. When we have 1 over feet cubed over a minute, this is difficult because we have to see where everything goes, and the feet cubed stays on bottom, but the minute could go on top. Because if you have a, I don't know if you like x or if you like x's and y's, but we kind of have 1 over x over y is the same as 1 over x times y to the negative 1, which is then the same as y over x, where now y is to the positive 1, x is to 1, x is to 1. So there is a little bit of exponent shuffling we need to do in this case, but we are still saying that there is this relationship that we're going to try to then do 1-to-1. I want to know if I have 1 cubic feet and 1 in 1 minute, how does that relate to my final units? And so I'm kind of thinking to myself, okay, great. I know that there is a similar relationship of, let's get rid of this. So if I know that 1 feet cubed is equal to 28, I wanna do this with colors. So I have 1 feet cubed is equal to, we've already looked this up, is 28.31685 liters. And we also saw that 1 minute equals 60 seconds. We know then that this 1 foot the foot cubed is still down here. Well, I'm kind of going over it again, and I don't want us to do that. But if we know these things to be true, this is then still, let's kind of highlight it in black a little bit, right? All I would do is rewrite this kind of thing here, and then they're rearranging the units on me, where they're kind of saying, well, when the foot is down here, it is in the denominator, so this is also can be described as foot to the negative 3 if I had it in the numerator, but it's in the denominator here, so that makes sense, and it is per 1 minute, which is when I place it in the denominator, when it's foot per minute and it's in the denominator, it really is quote unquote on top, which we have here. And so the number then we need is, what is this number? We need the liter per second conversion. And so that is already set up for us to do liters per because that's what I see up here. It's going to be in liters per second. That will cancel out my units and give me the units I want. And so I'll go into my web browser, 28.31685, divide it by 60, and I get 0.4719. And so we'll go back here and say, okay, maybe this is what they have a unit for us for. So let's, or if they have this number, let's go looking for it, 0.417. Okay, still not here yet, but let's see if there's any approximation of it. Interesting. Okay. Well, we're still not there yet. We basically now solved this question 2 different ways, but still not in the way they want us to do it. So let's keep figuring out how do they want us to do this. I'm going to bring it back just a bit. Okay, are any of these? No, I don't think they are. I wonder if they want us. No, I don't think they'd want us to do that. Oh. I think I did this right. Let's make sure I did it right. 1 cubic foot. Yep, that's right. 1 minute and 60 seconds. That'd be liters per second. Oh, cool. Okay. So let's, and is there any, oh, wait. You can add factors, I think. I think this is me misunderstanding how they handle it. Would you try something for me, student? What happens when you click add factor? Can you add another one of these? I think it's that I don't understand how this active works. So you see how there's this thing here? What happens when you do this? Does this add another box that we can factor more to? I think that's what we need to do. So let's have us, I can do this on my end like so. That's, I think, what our issue is. So, okay. It's fine that they don't have the numbers we want. I mean, the numbers here will work. We just need to, I think, add more converting factors. So if I add another one of these here, I think that's something you can probably do. And then you also probably can add an answer to it. We're learning active. How do I do this? I think it's like this kind of. No, I want to crop it all the way in. I get what it is, I think, more and more, guys, how to do this. So I bet that's probably part of your issue. You can, okay, great. So, okay, let's pause then and go back to where we were. We have this. We have this. I still like that. Okay, let's get rid of the feet cubed first. Let's see if we can do that. So I'm going to say I have feet cubed on top. Let's see if I can grab a feet cubed just by itself. I can. So I'm going to put a feet cubed on bottom. What can I convert this to? So let me make a little note here again. And let's crop this so it's a little cleaner. Right, so ask yourself again, and I think you already know this. Yeah, so it's like, so feet cubed is a volume. It is a way to describe how much something in 3D space. I said with my cell phone has 3 dimensions to it that can describe how much volume this takes up in the world. But I don't have to describe this in feet cubed, inches cubed. There are other ways to describe volume. And And gallon, right? You get a gallon of milk is a way to describe volume. But what should go in the numerator here? What do we want to convert feet cubed to? And go back and kind of check my my initial one here. What did we convert it to before again? Oh, wait, I forgot there is an issue with this, isn't there? Oh, I already remember the issue that we're going to run into here. I get what we're probably going to do. So let's go a second and look at base units for SI. So for a gray, let's say a length, meters, do they allow us to convert to meters? They let us convert to inches, to centimeters. We need to figure out where they're going with their units. They may be asking us to convert ahead of time because we can't go right to liters. Yeah, I'd like to. I'd like to do that, but we can't, it seems. So we need to find another way to liters. It looks like we need to go to another unit of volume first. So what units are volume? And I would say one of them is centimeters cubed. What we're looking at right now, if I can expand this out. All right, as I'm looking at all these units, let's go through them a second. This is not volume. This is liters cubed. This is a lot of... This is almost outside of my 3 dimensions that I'm commonly understanding. So this is not a volume. This is not a volume because it has something to do with time with it. What about this? Is this a volume? Oh, what am I saying? It obviously is. It's in the question. You know this one is. So this one's a volume. This is not a volume. This is just a measurement of distance. This is one measurement on my cell phone. My cell phone is amount of inches long. So that's not a volume. Centimeters is not. This has time in it. That's the one I noticed. Again, not one. What about that one? Is that one a unit of volume? It is. So we need to maybe consider, maybe they're bringing us to inches cubed, seconds, liters. No. Oh, that is a unit of volume, but we can't directly convert to it. Minutes is time. Milliliters cubed. Nope. That's, again, way past the 3rd dimension that I'm used to. But milliliters is a unit of volume. And so let's get out of that for a second. Bring it back down. And so I'm just going to see a second. Let's see if there's feet cubed to centimeters cubed. 28,316. Oh, another thing we could do. I forgot about this. What is this number? Do we have that number anywhere? No, I don't think we do. Not quite. We haven't quite found the thing they want to convert it to. Feet cubed to, what is our other one? 2 milliliters maybe? Or 2 inches cubed? 1728. No. There's no way they would do that, right? I gotta get my calculator a second. Yep. So I agree. We've got lots of volume units. We got to figure out which one we have a number that we can use. And I'm not finding one immediately. The reason I got a calculator is I'm also curious that there are other ways we can put, anytime we have a descriptor, so let me show on my iPad a second. Why I got a calculator is that anytime we're given a unit, not only is there, as a good example, not only is there 60 seconds in 1 minute, but this is exactly the same as me also saying there is, and if I do in 1 second, there is 0.016 repeating minutes. And so that is another way that active might put this back down. Wait, that's that one. Where did it go? I just don't want to show any student stuff, so let me quickly pause that. There it is. Okay. Okay. So we need to find in here, is it ever doing something like this weird to us? Man, why can't I do that? Yeah, none of those work. So liters is out. Okay, so we can't do liters either way. So what is the next one I wanted to look at? We looked at centimeters cubed, but I don't think that worked either. All right, let's just go back here. Feet cubed. Choose centimeters cubed. So I want 1 cubic foot to 1 that. All right. It's just a bigger. It's a bigger version of the centimeters cubed. Is actually quite. You'll notice it's actually quite similar to liters because it comes from milliliters, and milliliters and centimeters cubed are equivalent. But I don't think that this is our conversion factor either. If I do. Nope, I don't see that one. Okay, so I don't think it's a straight conversion to centimeters cubed. And so milliliters should be a problem too. We can't go right to liters. Can we go right to inches? I don't know why we would do that. 1728, I don't think that's in there. Tricky, okay. Well, even I'm, I guess, a little bit confused as to what they want us to do. Maybe we deal with an easier one to start. Let's see if we can do an easier one. So let's look at time for a second. If I want to get rid of time, I would put my minutes on top because over here minutes is down bottom, so I want minutes to go away. And ideally, I can convert minutes right to seconds. So let's try and set that one up. And do we have numbers for those things? Yay, okay, we do have those numbers. So we have a number 60, so that helps. There are 60 seconds. Okay, so that's that one we were able to deal with. But this feet cubed thing, how are we going to break feet cubed apart? Do they want us to bring feet cubed to just a foot? Do we have that? We could do that. Let's try. So, what can we do with a feet cubed to make it more? What am I missing here? I'm trying to see if these numbers can help me at all figure out what we're supposed to do with the volume aspect. Let's. Well, how do I want to? So let's look at what do they have for feet to centimeters. 30.55. No, I don't think that's going to be part of it. So I'm right now trying to find other conversions that this active wants me to look at. And maybe there was some sort of way they have us solve these things that I'm not aware of. I kind of explained it the way I approach these questions. Let me see about this a second. Maybe they want us to go to inches first? Do we have a 1 and a 12? Maybe. Okay, let's try that. So there, I'm seeing some numbers here that make some sense to me. So if I have a... Again, I just want to remind everybody who's watching this, I don't exactly love how they're making what they're making us do right now, but it's an interesting discussion for these things. So we have a feet cubed could be converted to an inch cubed. And I know probably, and a lot of people probably know, I have a meeting that starts at 5, so I'll go to the end of this. What time is it? I have to go 2 at 5. Yeah, no, and I think that I'm finding a way forward for how they want us to do it. So I'll probably end with this, but we know that there are how many inches in a foot? Well, in a foot there is 12 inches, and beware, I'm making a mistake right now, so don't think that this is the answer. Don't walk away from this just yet until I explain what's wrong with it. Because I think this will leave you with enough to do. So this is not yet right. This is converting a single foot to 12 inches, but that's not what we're doing here. We're saying, what about 3 feet? 3 feet, so a foot cubed. So not 1, but the right thing to put here would be, well, technically I'm taking a 1 foot and I'm cubing it. How many inches is that? Well, that would be 12 cubed. And so I'm going to take the 12, the number to describe my conversion that I know from feet to inches. And now I have this. And so I'm going to move this off to the side. I'm going to need a new one of these. And now I can say, well, now I've got inches cubed. let's see if there is any way to convert inches cubed to something else. So let's say inches cubed to centimeters cubed. If I have 1 inch, I have 16. Is that a number that could be in here, maybe? No, but what about this number? Not necessarily. Well, there's more work to be done, it looks like, but I'm going to leave this question here and just kind of show you that I want to approach this question in a little bit different way than active does. I'm solving it the way that you probably would do it with a pen and pencil. But active is in a way making it kind of a silly-ish game, a game with requirements where we're forced to use only the units they provide and only the conversion factors or the numbers they apply. And so what we want to go through is consider, always make sure that our units are canceling if we want them to cancel. So my minutes on bottom here, my minutes on top here. Seconds is down here. That's where I want it, my final answer. So this is done and good. Over here, feet cubed is on top, feet cubed is on bottom, inch cubed is on top. So the next thing I need to do is figure out how to get away from inches cubed and keep working my way to liters. Maybe they even have, let's just even see. Can we go right from inches cubed to liters? Probably not. We might need to go to milliliters. So let's see if I have one of those. Okay, great. But what if I have 1 liter? Then it's 61. Is that number in here? No. Well, there's 60. So there's something kind of close. So maybe we can go right to liters, possibly. But if not, what if they took us to... I said centimeters cubed, right? But anyways, I'll leave it there. It is a game. We can come back to this later if you're still not sure how to solve this question. But I'm going to say, I'll just leave a note here. This one is tricky because we are playing a game with forced boundary. We need to use their units and conversion factors. This is not what we always do or commonly do in the real world, but does a good job making sure you understand how to play or mess with units. So a good exercise, not great at showing real life. So before you leave, Kemya, do you have any questions, Kemya, before you leave? I think that this is a tricky question, but it's tricky because it's not how we would really approach it. It's forcing you to kind of mess around with it. So I've started to show us some ways to get to the answer. I kind of showed you what I wanted to do to solve it instantly, and we know what the answer is. And so that's another nice thing too, is if we know what the answer is, if we know on my iPad that the final answer should come out to be 210 times 28.31685 divided by 60. The answer is about 100. And let's see. Or did I do that right? Yeah. Oh yeah, it's right here. So the answer is 99. So we know the answer is going to be 99 at some point, but we got to figure out, we have to follow their ground rules. How the heck do we get here? All right, we know that the answer is... We know the answer is 99. We just gotta get there using the boundaries put on top of us. So I'll leave it there, and I think that's where I'm going to stop the stream. I'm just going to wait to see if Kemya has any other questions before I leave. But yeah, great. I think that's done. I think we're okay. So just checking again, last thing before I head out for today. Any questions before I go? Last second. And I say now how you do it in the real world. You can do it like this. But I think that my way of doing it, like if I had access to the internet, I don't know the liter to feet cubed off the top of my head. And so if I was forced to think about other things, that might be tricky, but leaving it there, guys. So again, just drop any questions here, drop them on Canvas, drop them in the Discord, and I will see you guys later. So 10 seconds until the question comes in. 9 seconds. 8 seconds. 5 seconds left. All right, guys, I think we are good. If you have more questions, who knows? I might stream a little bit over the weekend or be in my office a little bit over the weekend. But I will be back for sure on Monday during normal class times. We do have Labor Day. I'll be in my office anyways, helping with ECCP stuff and getting our class. Continuing to be the best class ever. But yeah, we'll play with units more when we come into class on Wednesday. I'll kind of do another version of what you saw here. And maybe I could even ask students too. Or some students might want to look at this before class. Who knows? But going once, going twice.